phones and all. I want to get that garbage out. Okay, let's take a look. Okay, first one. What's our strategy with this?
Combine
Good.
like terms.
Okay, we're combine like terms. We're going to put it into standard form, meaning get it all in one side. Perfect. Okay, so that's one of our strategies that we currently have. I end up with x squared, what, minus 3x minus 4 equals 0, right? And so when can we isolate x there? No, we can't. So what's our only option at this point? Factor it, and use the zero product property, right? Okay, so are there magic numbers that multiply to -4 and add to
Yes.
Yes.
Negative 4 and 1.
-4 and 1? Okay, so what are our solutions then? Either x equals 4. Perfect. Okay, you're good at that. You can do that stuff. Okay, and just to kind of ease your mind a little bit here, like I say, and you're going to appreciate this, the extent of this here in a little bit. I went overboard on the factoring hard quadratics because you're not going to, if in the future, you're just absolutely not going to do that. I'm going to give you a strategy today, for example, that supersedes factoring quadratics where a is not equal to 1. We're going to come up with something better than that so you can avoid having to do that. Factoring will be useful to you in situations like this, where factoring is really simple. Where it's hard, I'm not going to throw those on. I'm going to maybe have you do one of those on the test just to show me that you can, but I'm not going to load you down with those on the test because it's not that valuable. You're not really going to do that to solve quadratic equations anymore. Okay, what about this side? This is different, but this is our other strategy. What do we do here?
Isolate x.
Isolate x, good. Okay, we can point to a single x, and so therefore we can isolate it by reversing order of operations. Now, what would be the steps in order that we would have to use to isolate x? Okay, subtract 25.
Divide by -4.
Divide by -4. Square root, and then subtract 1 or add -1. Same thing, right? Okay, so let's do that. So if I subtract 25, what am I going to get on this side? -100, so let's just do that. Just -100 divided by -4 gives us the quantity x plus 1 squared is 25.
25 square root is
5, so a square root both sides.
Plus or minus.
Good, we got the plus or minus, good. And then last step?
-1.
Okay, subtract 1 or just add, even better, we'll just add -1 there in front of the plus or minus. And now we got both solutions. So what's one solution? X
-1
equals,
plus 5.
okay, which would be,
4 and -6.
right?
Yeah.
Okay, done, got it. Okay, but, there's always a but. How about this one?
Couldn't tell you.
That's a trickster.
It's gonna be a trickster. What does it look like we're gonna do here?
Minus
Okay, it looks like we're gonna subtract 9 and factor, right?
Oh, yeah.
Okay, but let's try that.
There's no solution.
No, there are solutions.
You just can't find.
Exactly, there are solutions, but we just can't get at them yet because we don't have a strategy for that. We're stuck. We can, at this point, up till today, we can only deal with quadratic expressions where we can isolate x or where they factor, hopefully easily, right? But we're stuck if it doesn't factor because we don't have magic numbers that multiply to -9 and add to 2, right?
Yeah.
Okay, so we want to come up with a different strategy. Now I'm gonna give you kind of the topic of the day is this is called completing the square, is what this technique is called. And you'll see why here in a little bit. But the goal of this essentially is to take a problem like this one that we're dealing with, and we want to force this kind of a problem to be this kind of a problem where we can isolate x. Okay? That's our strategy. Now, how are we going to accomplish that? Well, this is not the way, right? That didn't work. We're going to have to do something different. The something different is actually represented best by this little picture I got going here. You'll see why. This is kind of cool. Okay, so let me quite get it.
Rotate it just a little bit.
Just a tiny bit, there we go, okay? So now, remember what we're trying to do in this case is, and we're gonna be general, we're not gonna really just focus just on our example. We wanna take anything that looks kinda like this, and we wanna be able to deal with it. So on the left side, very generally, what we really have here is just an x squared plus bx. On the right side, the constant didn't fit properly with those two terms to give us magic numbers that work, right? So our strategy is, we're going to forget about the 9. We're going to try to add just the right number to this so that we can deal with this in a way where we can isolate x instead of having to factor, okay? Our goal really is to make it look like this. I'll even show you this. Our goal is to make it look something like this. X plus, say h, call it h, is fine. X plus h quantity squared equals some number, right? And if we could make it look like that, we could pretty easily isolate x, couldn't we? By just square rooting both sides and adding negative h, okay? Well, there is a trick for doing that. There is a trick that would allow us, if we can add just the right number to this, we can make it look like a perfect square trinomial. Now, what in the world is a perfect square trinomial? Let me define that term first. Perfect square trinomial is just this. A perfect square trinomial is one where we have something like ax squared plus bx plus c is equal to, and I won't even put the a in there. Let's not even confuse things with the a for now. X squared plus bx plus c equals x plus h quantity squared. Okay. If the trinomial can be written as a single factor squared, then that's what we call a perfect square trinomial. Okay, so an example of one that is a perfect square trinomial would be something like x squared plus 2 quantity squared. If I FOIL that out, I'm going to get x squared, well, what do we get? I mean, x squared plus 2x plus 2x is 4x plus 4, okay? I mean, we don't need to go through the work of FOILing it. Just trust me, that's what it is. That's a perfect square trinomial because it can be written as x, whoops, I don't want that squared there either. Hang on, let me get rid of this before you write it down. Because it can be written as x plus 2 quantity squared, okay? This is not a perfect square trinomial. This is a counterexample. So that is x plus 2 times x plus 1, which is x squared plus x plus 2x plus 2, is not a perfect square trinomial because it can't be written as x plus something squared. It factors into two different factors, okay? So our goal is, could we write this as add something to it to turn it into a perfect square trinomial so that x only shows up once and we can isolate x. All right, so in our picture here, on this page, our goal is we want to represent the area of x squared plus bx. Well, x squared, what is the area of x squared? I mean, what kind of shape would that make if we're looking at an area? It's just a square, isn't it? A square with sides of length x, right? So then this red area up here, whoops, is x squared, isn't it? That's x by x. It's a square, okay? Now, what about b times x? What kind of area would that represent? That'd be a rectangle, right? With one side length b and one side length x, right? So isn't the blue area up here? That's b times x, right?
Yeah.
And so this area that I've drawn here represents x squared plus bx. My goal is to turn this into a bigger square. Okay? Well, look what I can do. I can cut the blue area in half. And if I flip this around so it's close enough. Oh, maybe it's not close enough. to make a square, doesn't it? It's trying to make a square, but it's not quite. Now, if we could somehow turn this into a big square, what would the dimensions of that square be? What is the width of each of those blue rectangles now? Okay, x by half of b, because I cut it in half, right? Instead of going all the way over to b, I cut it in half, right? And so wouldn't you agree then that this distance from here down to there is x plus b over 2, right? And that's the distance from there over to there. But we haven't quite filled in the square. We need to complete that square, don't we? We need to add a little piece that fills in that corner, right? If I could do that, if I could add just the right piece there, so I filled that in, then this whole thing would just equal the quantity x plus b over 2 squared, wouldn't it? Right? Because I'd have a square of side length x plus b over 2, right? Everybody see that? Okay, well let's do that. It's going to be a little tricky here, and I'm going to do that. Voila. We filled in that little gap and completed the square, right?
You know what the square was, though.
How do I know? Well, you tell me. What are the I mean, I've got them written up there, but do you see that the dimensions of that square have to be b over 2 by b over 2? Because isn't it the width of the bottom blue rectangle and the width of the vertical blue rectangle?
So
Right.
what is that?
Okay, so that tells us then that if we just add the little extra piece, b over 2 quantity squared, we're going to get back a perfect square trinomial. Okay? Now let's just, before we go any further with this, let's just practice that. I want to give you a couple examples, and you tell me what's the number I would have to add to get a perfect square trinomial. So what if we started off with something like x squared plus 8x plus what number would be a perfect square trinomial?
16.
Okay, it would be 16, wouldn't it? Because if we look at our picture, right, whatever b is, and in this case, what's b? 8, right? Okay, we know that the perfect square trinomial we're going to build is just x plus b over 2 by x plus b over 2. So its area is going to be x plus b over 2. Well, b over 2 in this case is just, b is 8, right? So that's going to be 8 over 2, which is just 4, right? Quantity squared. Well, if I'm adding, what I had to add to the x squared plus bx term to make that happen, remember, was the square of b over 2. That's the number I had to add to fill in that gap and complete the square, right? So I have to add up here. In order to make that happen, I have to add 8 over 2 squared.
And would you simplify it?
Well, okay, yeah, we would, right? But yes.
So which one are you trying to find both of them?
Well, so what we're trying, our goal at this point was to be able to turn this x squared plus bx, instead of having two individual separate x's, an x term and an x squared term, our goal was to add just the right amount so we could write it as a single x plus some number squared, right? And so in this case, if we simplify that, isn't that just, we end up with x squared plus 8x plus 16 can be replaced with the quantity x plus 4 squared. Right?
Yeah.
Okay? See what I'm getting at? Okay, let's try one more of those. You're going to fill in the blanks for me.
So are you trying to like find a zero?
Well, okay, yeah, and we'll get to that in a second. So just for now, just focus on this one little skill, and then we'll go put it into play and actually solve the problem with it. Okay, so what if we had something like this? If we wanted to complete the square, we had x squared minus 6x, and I want to write that as x plus something squared. What's the magic number that I have to add?
6 over 2.
Negative 6 over 2 is negative 3, so that's b over 2, right? So that's the number that's going to go there, right? And up here we'd have to add 9. that number squared, b over 2, which is negative 3, squared.
How did you get the negative 3?
Because b is negative 6. It's always half of b. Okay?
And then that was the negative 6 over.
Oh, and
2. Wait, how did you get the 9?
Because I have to add b over 2 squared, right, to get this.
And
Right?
doing the second equation just makes it, make sure it's a square.
Well, and then the whole point is if we add this little extra area, then we get this more convenient perfect square trinomial.
Yeah.
And so the moral of the story is anytime you start off with an x squared plus bx, you can always add the correct number, add just the right number to make it into a perfect square trinomial, which effectively is just adding that little orange area. Okay? Yes, sir?
And then, I don't know, after we do that, this is wrong, I think, but we'll be able to factor out.
Yes, okay, so, well, no, we won't factor,
Yeah,
we're
because
gonna
we'll
avoid
have
factor. So here's what we'll do, so now let's finish our problem. Let's use this little trick we've got going.
This
And
trick
let's-
doesn't work if it's not a perfect square.
No, it works anytime, because you're gonna force it to be a perfect square.
Okay.
Okay, so if we go back to our problem here that we're working on,
Okay.
let me just erase this stuff, and we'll just finish this problem up. Okay, so we've already got this 9 on the other side, right? What we want to do is we want to add to the left side, we want to turn the left side into some quantity squared. So we're going to say x squared plus 2x plus some number, and I'm going to add that number to both sides, right? Does that make sense? There's no reason for us to push this 9 back to the left like we did the first time. We don't want to. We want to have just the x squared plus bx on the left, and everything else we're just going to shove over to the right to get it out of the way. This is what we want to work on. We want to take this x squared plus 2x and add just the right number on the left side to make it something like that, right? Okay, so what's b? No, what's b?
Two.
b is 2, so then what's the number that we're going to square?
1.
1, half of 2, right? b is 2, so b over 2 is 1. So we're going to add 1 squared to both sides, which is just 1, right? Which is just 1. And then what does that give us down here? Well, it gives us x plus b over 2 is 1, quantity squared, right?
Yeah.
Okay, now so look what we get on the left side. On the right side, we just get 9 plus 1 is 10. Okay, now that's easy, isn't it?
Yeah.
Look at that, it's one simple step. Look what we've done. We've rewritten this in a way where now it's a piece of cake to solve this thing. We couldn't solve it before, but now we can. Now this becomes like a 5.3 problem, one of those where we just isolate x, right? What are the 2 steps in order to isolate x there?
Square root both sides.
Square root and subtract 1, right? Yes.
What if it wasn't 2, but it was 7?
Okay, we'll do one like that, sure. It'll still work. It's just gonna be a little less convenient, but it'll still work. Yep.
I don't know if you get into this, but is there any difference if there's a variable and if there's an a in front of the x?
Okay, there is. Now, I'm not gonna mess with that yet, but it's not that much harder. And here's what I'll say about it for now. Remember that we, instead of pulling the 9 over to the left side, we just pushed the 9 to the other side because we just wanted to only focus on the x squared plus 2x. If there had been an a out in front, couldn't we just divide both sides by a?
Yeah.
Right? And that means, get rid of it from the left side. Sure, we're gonna get a fraction on the right side, but who cares, right? The right side's just some number. Does that make sense? Yeah.
Can you do the rest of the rest?
Yeah, let's do
That
it.
was true.
Yeah.
Would it be negative 1 squared?
So we get
Plus or minus?
x plus 1 equals
Square root
the plus or minus square root of 10, which doesn't simplify, right? We're gonna add negative 1 in front of the plus or minus, and so we just end up with x equals negative 1 plus or minus square root of 10, and there's both our solutions. Now in Moodle, you're gonna have to write them separately, right? I want one of them is negative 1 plus radical 10, comma, negative 1 minus radical 10. The opposite way is fine. It doesn't make any difference. Okay? Let's try another one. Try this guy. Okay? Take a second and see if you can set that up. Now, okay, but something else too. Just because, and it's probably okay to do this now because we're focusing on this new technique of completing the square. But at the end of the chapter, I'm just going to give you quadratic equations and say solve them. And in fact, I'm even going to have a test that's not an algebraic test, which is just, there's a part of it that's going to say, okay, what's the best way to solve this? Is it completing the square? Is it factoring? You got to be able, so we always want to try the easiest thing first. So what are we going to try first here?
The thing you just was x squared plus 12x was the 0 on the.
Okay, right. We're going to put it in standard form first and see if there are magic numbers. And if there are, great. That's the easiest way to solve this thing, right? If there aren't, then we'll move to plan B. Okay?
There it is. Oh, there it is.
Are you sure about that?
Yeah. Well, no, because there's a negative in front. No.
I don't know, I just don't think you put one up there that works.
No, there isn't because it makes it just positive.
Be careful about the signs, though. I'll tell you right now, there aren't magic numbers, but I want you to verify that for yourself.
Why are you solving?
Oh.
There isn't. Because
Like, after you
28 times
it would make it a positive.
You look at my paper and say you don't know.
Yeah, I'm confused now.
Oh, yeah.
Wait.
Oh, wait. Because you have to move to 20. And then you find 20.
Okay, so first of all, real quick, we'll just try this. If I put this in standard form, are there magic numbers that multiply to positive 28 and add to negative 12? There aren't. Now, if that were a negative sign, there would be. Then I'd have negative 14, positive 2, but it's not. It's positive 28, so the numbers have to be the same sign, and they don't exist then, right? Agreed?
Yeah.
Okay, so we really don't want it in standard form after all. What do we want to probably do instead?
Put it in the weird form.
Okay, put it in the weird form, in the completing the square form, which means we want to keep what on the left side?
The negative.
The X.
X squared.
The x squared and the minus 12x, because that's what we have to build the perfect square from, and we push all the other junk to the other side, right?
Wait, isn't that a negative x squared?
Well, no, you'll see.
Because you subtract. Oh, I gotcha. Because you, yeah. Never mind. 'Cause you was that. Yeah, you don't.
Okay, so then now we're going to complete the square, right?
Yeah.
So we want to add to that just the right number to create a perfect square trinomial. And it's going to be negative 6 is b over 2, right? So we know if b is negative 12, we're going to create the perfect square trinomial x plus negative 12 over 2, which is negative 6, right?
Yeah.
So x plus negative 6, or x minus 6 squared, is what we're going to get. But what do we have to add to get that? Yeah, we have to add b over 2 squared, right? Okay, which is what? 36. So I have to add that number to both sides. So over here, I'll just write it as a 36. Because, okay, makes sense?
Oh, I was confused on that.
So then what is the number we end up with on the right? 8, okay? And now it's easy, right? Now it's just an isolate x problem.
Yeah. You want
Okay.
to do that?
I don't care. What are the steps we'd go through to isolate x? Yeah, square, plus or minus square root, add 6 in front of the plus or minus, right? Okay. All right, so, whoops, I want to do
I still don't agree.
Okay, try this one. Try this one real quick. Whoops. Okay, no magic numbers, right?
No, sir.
So we'll push the constant to the other side and complete the square.
Oh, I meant.
Okay, now what's B?
Three.
Wait, 3.
Okay, B is 3, right? So what's B over 2?
3.
3 halves or 1.5. I just leave it as a fraction. Okay, so then we're going to end up with the perfect square trinomial. What squared?
3 halves.
Well,
X
x plus 3 halves. Good. X plus 3 halves quantity squared. Okay, good. Now to get that, we have to add what?
3 halves squared.
3 halves squared, right? Which is what? 9/4.
So that one we have minutes.
Okay. Right? So then we end up with our perfect square trinomial, x plus 3 over 2 squared equals, what is that? What does that simplify to?
13
Okay,
fourths.
13 fourths, want it as a fraction. So 13 fourths. Right, 4 fourths plus 9 fourths, okay? And now it's pretty simple. What do we do to isolate x?
Square root.
Square root. So let's finish this one. So x plus 3 halves equals plus or minus, right?
Yeah.
And really we're just square rooting both sides. So what does the square root of 13 fourths simplify to?
Square root 13 over 2.
Perfect. 4 is a perfect square, isn't it? So we end up with square root 13 over 2. And then the last step would just be,
Minus.
yeah, add the negative 3 halves in front of the plus or minus, and we got both our solutions. So x equals negative 3 halves plus or minus the square root of 13 halves. And if you want to combine everything, I mean, that's great. That would work. If you want to, you could also write that as negative 3 plus or minus radical 13 over 2, right, with a common denominator. Either way is fine. Okay?
Yeah.
All right, so then the coup d'etat then. So what would we do if we had an A out in front? I just want to show you that it looks scary, but it's not that big a deal. Okay, let's take one of these, and this is it.
Is this going to be on our assignment?
I will give you a couple of these to do too. Yeah, but they're not. It's not a big deal. You'll see. Okay, let's do.
Can you also explain how to do the fractions?
Sure. Sure. Okay, so let's try. How about? Okay, what about this guy? Okay, now I'm going to suggest here that it doesn't even matter. It doesn't matter if we can factor this or not, because factoring it is not going to be fun. So let's not even do it, right? We're going to have to do A times C, then split B, that's not fun to do.
Are we going to do this?
So we're going to do this. So we'll do this with our new trick. So first of all, let's get everything on one side. But remember, we always want to have the leading coefficient be positive, right? So which side are we going to push stuff to?
The right.
To the right, because we want a positive number of x squares.
Oh,
Okay, because that's the leading coefficient, meaning the coefficient of the biggest power of x. So if we push everything to the right, we get on the right side, we're just going to get 4x squared minus 20x. Agreed? Okay. Because I'm gonna subtract 21x to get it on this side.
I'm sorry,
right?
I did it the other way.
Plus 13 equals 0, right? Or equals 0 on this side, but let's just put the 0 over there instead, right? Okay, we good?
Sure.
Okay. All right, so now remember, to complete the square, we just want to get x squared plus bx by itself, right? Okay, so the first thing we're gonna do is we're gonna subtract the 13 to get that term away, right? So that leaves us with 4x squared minus 20x equals negative 13, right?
Wait, what is the negative, the 4 being negative?
No, because we added the 4 over to this side.
Oh, okay,
Okay, does that make sense?
Yeah.
Okay. And now, we don't want that a in there. We want it to look like x squared plus bx on the left side. So what would I have to do to, I got to divide by 4, right? I'm going to divide both sides by 4, which is the same thing as factoring out a 4 and dividing by 4, right? But I could just do this.
But that doesn't go to negative 15.
That's okay. It's just a fraction then. It's okay.
We love
Right, so now if I divide two terms by 4, I'm just dividing them individually, right? Okay. So then this looks like on the left side, first term is going to be what?
X squared.
X squared. Second term is going to be,
Minus 5x.
okay, and then over here, we're just going to get negative 13/4,
Do
right?
you have to divide the negative 20x if you?
You do. You have to because we, and this is the same thing, by the way. We could, if we wanted to, think of this as just factoring out a 4. And what are we left with if we do that? X squared minus 5x, right? And then we would just be dividing both sides by 4 to get rid of that. Okay, same exact thing. I think it's a little easier, there's fewer steps to show if you do it this way, but you can do that either way. But now look what we've got. Now we've got a problem that is just like the ones we did, isn't it?
Oh.
Right, that's no big deal. Now all we have to do over here, right, is rewrite this as x plus something squared equals something. What's b in this case?
Negative 5.
Okay, negative 5, so then I'm going to have x minus 5 halves quantity squared.
Yeah.
And then up here, we're going to have to add negative 5 halves squared. Right? Well, what is a negative number squared is always positive. So what's negative 5 halves squared?
25 fourths.
Yeah. So that's what I'm adding to the other side, right? This, I should have written this in orange. This is that extra piece that we have to add to both sides, right?
Yeah.
Okay. So then we end up with x minus 5 halves quantity squared just equals that. Well, 25/4 minus 13/4 is what? 12, which is 3. How about that?
Is it?
Just the.
Yeah, just 3.
I got
Right?
Yeah.
And so we end up with then, if I square root both sides, x minus 5 halves equals plus or minus,
Wait, so.
right?
Yeah, I have a question. We didn't do that squared, negative 5 squared.
Negative, well, because I have to add b over 2 squared, right, to get this. The only reason I have to write that there, though, is so I know what I'm adding to the other side also.
So you just kind of ignore it?
Well, I don't really ignore it, because I have to know, I have to add just the right piece to make a perfect square trinomial, right? And so I know I'm gonna end up here, but I gotta know what I'm adding to the other side, how that's gonna change the other
Then
side.
you don't need the negative 5 there just to tell you what that is, so why do you need to write it?
Need this, you mean?
Yeah,
Just so my equation always stays balanced.
but you don't use
Yeah, you
it.
don't really use that, do you?
So like
You
you
just use it over here.
put it at all when it affects.
No. Okay, so hey, let's finish this up. So last step, add 5 halves. Done. How about that?
Yes.
Okay?
That was easy.
Isn't that, that's, you gotta admit, that's pretty cool. You can do that. What's that? No, that's, doesn't get any harder than that. That's it. That's it.
I don't believe you won that.
Can we play the game now?
The game? Oh, okay, sure.